Lymphoid tissue is connective tissue with a lot of lymphocytes. There are lymphoid nodules, which are just clumps of lymphoid tissue. But there are lymphoid organs, and the difference between an organ and a nodule is that the organ is surrounded by fibrous connective tissue, like a little capsule. And the lymphoid organs include the lymph nodes, the thymus, and the spleen. So the lymphoid nodules are clusters of lymphoid tissue, and they're found in tracts opening to the external environment. They're deep to the epithelia lining these passages. As a group, these are called mucosa-associated lymphoid tissue, or MALT. 3 locations of large lymphoid nodules in the wall of the pharynx are the tonsils. The adenoids or pharyngeal tonsil is on the posterior superior wall of the nasopharynx. The palatine tonsils are located in the posterior inferior margin of the oral cavity. And the lingual tonsils are deep to the epithelium, covering the base of the tongue. And tonsillitis is a swollen tonsil due to infection. This is showing a MALT mucosa-associated lymphoid tissue right there in the large intestine. And you can see the locations of the pharyngeal, the palatine, and the lingual tonsils. Lymph nodes are small lymphoid organs shaped like a kidney bean. These function like a water filter. They purify the lymph before the lymph reaches the bloodstream. Almost 99% of antigens are removed from the lymph. The immune response is stimulated as needed. So you may recall the term afferent and efferent. Afferent is bringing in, efferent is bringing out. So afferent lymphatics bring the lymph. It would be dirty lymph into the lymph node with pathogens or antigens that need to be removed. And the lymph will flow through a network of fibers and dendritic cells. And this is kind of the beginning of our immune response, this flow through the lymph node. Regions in the lymph node contain B cells and plasma cells. And then the efferent lymphatics will carry the lymph out of the node toward the veins. So here you can see the flow is coming in on this outer curved side of the lymph node and flowing out here. The thymus produces hormones important to the development of functional T cells. Several complementary hormones are known as thymosins. And the size of the thymus and its ability to secrete thymosins declines with age. This is correlated with the increased susceptibility to disease. There's the thymus, below or inferior to the thyroid gland. The spleen contains the largest mass of lymphoid tissue in the body. It has the same function for blood that lymph nodes perform for lymph. So it removes abnormal red blood cells by phagocytosis. The iron will be stored there from the recycled red blood cells. And in the spleen, the immune response will be initiated by T cells and B cells. The spleen is in the left upper quadrant. Which of the following is the largest lymphoid organ? The spleen. Which of the following lymphoid organs is important in development of T cells? The thymus. Which of the following is not a type of tonsil? Maxillary. Through which lymphoid organs does lymph flow? only lymph nodes. Immunity is the ability to resist infection and disease. And we have two types of immunity that work independently and together. There is nonspecific or innate immunity that we are born with. And there is specific immunity that adapts to what we're exposed to. So it's called adaptive. Nonspecific immunity or innate immunity does not distinguish one type of pathogen from another. The response is the same regardless of whatever it is that is invading us. So it is nonspecific. Nonspecific defenses include physical barriers, phagocytes, immunological surveillance, interferons, complement system, inflammatory response, and fever. Specific defenses protect against a very particular pathogen, and it depends on the activities of specific lymphocytes. Specific resistance develops once you're exposed to a pathogen. The integumentary system provides the major physical barrier to invasion by pathogens. Glands, such as sebaceous and sweat glands, secrete liquids onto the surface, so it flushes the surface, washes away microorganisms and chemical agents, and actually can contain bactericidal chemicals, destructive enzymes, and antibodies. Hair protects against mechanical abrasion and often prevents hazardous material or insects from contact with the skin. And the epithelial covering, as you may recall, has multiple keratinized layers and a network of desmosomes that lock the adjacent cells together to prevent flow of any organism between the cells. Epithelial barriers line tracts, such as the digestive, respiratory, urinary, and reproductive tracts. These epithelial barriers provide a physical barrier. They often secrete enzymes, antibodies, or acids. Acid is produced in the stomach to destroy many pathogens. Mucus in the respiratory tract traps pathogens. Urine flushes away urinary passageways, and glandular secretions in the reproductive tract flush the tract. And malt as well provides non-specific defense. Phagocytes are the first line of cellular defense. They are found in peripheral tissues, and they remove cellular debris. They will respond to invasion by any foreign agent, a pathogen, or a compound. They can attack and remove microorganisms before the lymphocytes detect the presence of that microorganism. And there are different types that target different threats. All function in the same basic way, though. Here is a phagocyte in yellow engulfing a bacteria in orange. There are different types of phagocytes. Neutrophils are very fast and abundant, and they will phagocytize cellular debris or invading bacteria. Eosinophils are less abundant. They phagocytize foreign compounds or pathogens that have been coated with antibodies. So a virus, our cells can't recognize a virus to phagocytize it, but once it is covered with antibodies, then the eosinophil can phagocytize. And the monocyte macrophage system. So monocytes are a type of leukocyte, and once the monocyte leaves the blood, it becomes a macrophage. And we have free macrophages and fixed macrophages. The free macrophages travel throughout the body looking for some type of pathogen or infection, and the fixed macrophages are scattered around in our connective tissue. Phagocytes can leave our capillaries by squeezing out between the adjacent endothelial cells, and this is called diapedesis. They are attracted by chemotaxis, or chemicals in damaged cells. So they're sensitive to chemicals that are released by body cells or the pathogen. Receptors on the plasma membrane of the phagocyte bind to the surface of the target, and after attaching, the phagocyte either destroys the target itself or promotes its destruction by activating specific defenses. Which of the following is not one of the non-specific defenses? Cytotoxic T cells. Which of the following is not a phagocyte? Lymphocyte. Inflammation is a localized tissue response to injury, and it includes 4 symptoms: swelling, redness, heat, and pain. Inflammation may be caused by a variety of stimuli that kill the cells, damage the connective tissue fibers, injure the tissue, and the result is an altered chemical composition of the interstitial fluid. These damaged cells will release prostaglandins, proteins, and potassium ions, and foreign proteins or pathogens may be in the area, and this change in the interstitial fluid would trigger the inflammation process. Fever is a rise in the body core temperature above 37 degrees. Pyrogens, which are circulating proteins, reset the temperature thermostat in our hypothalamus. This can be beneficial within limits. First of all, the higher temperature inhibits some viruses and bacteria. Also, it increases body metabolism and quicker mobilization of tissue defenses and faster repair process. The summary of nonspecific defenses includes physical barriers, phagocytes, immune surveillance by natural killer cells that monitor the peripheral tissues, and these natural killer cells release perforins that actually poke a hole in the bad cell and kill the cell that way. Interferons are released by lymphocytes, macrophages, or virus-infected cells, and interferons trigger the production of antiviral proteins. They stimulate macrophages and natural killer cells. The complement system is really quite complex. All we're going to really learn is that it's a group of circulating proteins that help antibodies destroy pathogens. Inflammation, or the inflammatory response, is a localized tissue-level response to limit the spread of injury or infection. Fever accelerates the body's metabolism and defense activity. Which of the following chemicals triggers inflammation? Histamine. Which of the following is not an action of the complement system? Activate antibodies. Which of the following is the main benefit of fever? Increased metabolism mobilizes defenses faster.